Good afternoon, and welcome to the Music and Technology Seminar at Carnegie Mellon. Our guest today is Miles Scharff, recent graduate from Carnegie Mellon, where he studied physics and music technology. His list of accomplishments since he left CMU covers a wide range of projects and accolades, from exhibiting works in art galleries to performances involving radio electronics, sound sculpture, video, and spatial audio, and a Master's of Fine Arts degree from Columbia University. While a student at Carnegie Mellon, Miles was also a frequent and favorite recording artist and guitarist in the Vlahakis recording studio. Please welcome Miles Scharff to the Music and Technology Seminar.
Hello. Yeah, I'm really happy to be here. I'm happy to be looking back in the studio where I spent so much time. Also, I see that Tom and Richard are here, which makes me kind of nervous. So please be nice to my haphazard circuit techniques when I begin explaining those. Okay, so this is going to be like sort of half technical talk, half artist talk, half like historical survey, all surrounding the topic of electromagnetic listening. And I've included these two images on the title screen. I think they encapsulate my interest in this topic. I think I obviously have like a very strong technological interest, but really it's just an interest in, like how we relate to the immaterial. So this top right image is something called the spirit battery. This was back in the early 1800s where people would, hold hands, alternating genders, and connected to two buckets of water in order to like increase their connection to the dead, which I think is very interesting. And then down here is this image from a product sold by a company called Q-Wave, and it's supposed to protect you from harmful EMFs. My favorite of this list is, oh, where is it? Oh yeah, nullifies psychic attacks and dream intrusion. I think that's so amazing. Okay, so what is there to listen to? I wanted to give just like a general idea of like what kind of signals are going on the airwaves. Um, like obviously it's like a mix of natural signals and human-made signals. So, you have like antennas and other telecommunications, like all localized electromagnetic devices, like anything that creates some kind of like changing electric field, like an ATM or a phone or a computer, electric doors, like those sliding doors, like all of that creates, radiation. And then you also have currents in the earth, atmospheric events, like down here. This is a diagram of how like a cosmic ray muon decays in our atmosphere. That releases a signature. That's something you can detect and listen to. Up here is the United States frequency allocation spectrum. So everything in our sort of like telecommunications bandwidth, is divided up among, like AM and FM, obviously, but also, like things for just nautical communications, things for amateur radio people. And all of these things sound differently. And then I've included this thing down here. This is not really the range I'm working in at all yet, but 'cause it's so high frequency. But I think it gives a good scope. Like we see, we increase in frequency up to visible light. And I think it's important to remember during this talk that, as through our senses, hearing and sight, we only experience like a really tiny fraction of vibrating phenomena. Okay. So, what really piqued my interest in this topic was something called electrophonic transduction. And this is when, you're able to hear electromagnetic radiation through a physical object that somehow like the radiation interacts with the object and then makes an audible sound. Like it creates like actual air pressure waves. Or at least like pressure waves like in your body such that it vibrates your eardrum. Now, the most famous example of this is Lucille Ball, who's the actress for I Love Lucy. She claims, well, actually, I'll play a bit of the video. Let me know if you can hear this still. Oops.
Almost home.
Yes, good.
And I was passing 4 vacant lots that were all raised so they could build the Birmingham Hospital. And as I went by there, I heard, I'm picking it up on my teeth.
You mean?
Yes. And I stopped the car. Then I looked.
But I won't play the whole thing, but she goes to like the security at MGM Studios and they tell her that because she has a metal dental filling, she's picked up Morse code. And the story goes is that they were Japanese spies in a mountain in California, and that she helped catch them because she picked their signals with her teeth. This has been widely debated, and I'm not totally sure that this is true, but there are instances that are true. Another really famous one is that in Cincinnati in the 1930s, they were trying to broadcast AM radio to the whole world. So they made this 500,000 watt AM radio tower. And people in the immediate vicinity reported going to sleep and hearing, the radio through their bed. They had metal bed springs and like the really powerful radio waves were interacting with them and making them audibly sound. They would hear them through pots and pans or their wire fences. Another really famous example is in the 1970s, there was a war veteran who had a piece of shrapnel embedded in his brain that, it wasn't doing any harm, but it, wasn't safe to remove, so they left it in there. He was picking up the radio through that piece of shrapnel. It was like vibrating his skull and then vibrating his eardrums. They knew it wasn't hallucination because he was able to, match, what he was hearing to, what was actually happening on the radio. There's this really interesting video, which I'll play a little bit of it.
There are voices in the wall.
It may sound like an episode of the popular net 9-year-old Brianna Smith is hearing are real.
It's been waking me up at night.
They're coming from the bedroom walls of her suburban Lockport home in the middle of the night.
So you put your ear to the wall and you can hear the music?
We hear it audibly, and it's kind of, keeps us up at night.
Do you have a speaker in your wall?
No speakers.
Brianna's father, Richard, captured some of the late night noise on his phone.
You can hear the commentator's or the pastor's voice in the wall.
Right.
There it is. So you hear that voice.
So this is a family in Illinois. They had like an old pipe in their wall that wasn't connected to anything, but wasn't like removed when they updated their infrastructure. And somehow at night, it was audibly making noise from a Christian radio station nearby. And I think it's pretty amazing that they were haunted by a Christian radio station. But this is 2021, so this isn't like this isn't necessarily a thing of the past. Another thing here, auroras, like the aurora borealis, they produce like pretty intense natural radio signatures. And if you're really far north and it's really quiet and there's like a really strong aurora, people have reported hearing, pops and crackles and these atmospheric events through like wireframe glasses or the strands in their hair. And there's a really great book by Douglas Kahn called Earth Sound, Earth Signal that I think contextualizes this really nicely. They had invented the telegraph and they had a bunch of like really long unshielded telegraph lines. And in the invention of the telephone, they were using those same lines to see if they could communicate across them. And at night, you just have a telegraph line, some kind of amplifier, some kind of speaker. And people reported hearing really strange noises through this unshielded telegraph line late at night. And radio is much stronger at night because of the ionosphere. There's a great quote from that book that says the radio was heard before it was invented. Is you're hearing earth currents and wireless communications that exist before anyone's ever even invented wireless communication. So some electromagnetic listening that you may already be familiar with. The radio, obviously, is the most common one. And then, we're all in a music tech seminar, so I'm sure we all know about the 60 cycle hum that comes through our speakers. That's your audio equipment being susceptible to the AC power grid, which obviously oscillates at 60 cycles per second. And then maybe a little more esoteric, but I was introduced to these products when I went to CMU, so maybe some of you know about them. There's a website called LUmkA, and they have a whole section for electromagnetic listening devices, most famously the Electrosluch and the Priazor. And they sound like this. Yeah, so the idea with these is that you have you're trying to make the electromagnetic world like more accessible to music making or sound design or anything like this. And these devices are really simple devices. They work by Faraday's law of induction, where this is obviously a coil of wire, and at the end of here are two tiny inductors, so two tiny coils of wire. And when you have a changing electromagnetic field that you would have when you went to a computer or any kind of oscillating thing, the field moves through the center of the coil, and that creates a current proportional to the field. So you're transducing from electromagnetism into voltage that you can then amplify and listen to. And this is the circuit for one of these such devices. Super simple. You have your inductor here, your coil, some coupling, filtering capacitor, and then just like an inverting op amp. You can just listen to it. The next kind of listening device that's been used by artists is something called a natural radio listening device. So the band from 0 to about 11 kilohertz is too low frequency for communications. So it's mostly left alone by humans, aside for the AC power hum, which is obviously at 60 cycles and has harmonics. So if you go to a really quiet place with no power lines, you're able to hear atmospheric events. The most famous guy who's done this is this dude named Stephen McGreevy, who's made a lot of handheld devices. And what he's captured is pretty beautiful. This is him in Alberta. You get these pops and cracks and whistles and rising tones, and that's all natural atmospheric events, and all of that is based off of this schematic here, which is essentially just like a super sensitive whip antenna receiving circuit. Don't ask me too much about how this works because I'm still trying to figure it out. And this is obviously being used by artists. I'm sure, or I'm not sure, but I'd hope some of you are familiar with Alvin Lucier. Famously did "I'm Sitting in a Room." But he also released an album called Spherics, where he took a really, really long loop of wire and like a really big frame, and took it out to the desert and recorded this. So more of the same, but still quite beautiful. And yeah, I attempted to build one of these, and I went to Iceland to try and record, and that's what this sounded like. So I don't think the recording quality is as good as Mr. McGreevy or Mr. Lucier, but I'm still refining my design. Okay, next, and I think last receiver that I'm going to show you guys is the all-band receiver. This was made famous during the Cold War. It's a receiver that's basically just like a glorified diode detector, which basically amplifies the strongest signal that it's near. So, spies would wear the antenna and the receiver and, walk near a building where they think someone might be wirelessly communicating and try and intercept their communications. And this is pretty useful. People have used it on airlines.
101,
So it's somehow able to decode whatever frequency the pilots are transmitting on, which is pretty amazing. There's like a web page about it at the Crypto Museum, which I think is kind of interesting. And here's the schematic for this. So again, it's just like this diode detector thing at the front with then, some amplification stages. So a couple of notes on radio artworks, and I think this is necessary for like contextualizing some of the builds and projects that I'm about to show you. And I think, a lot of it's like in relation to this image, like people have been curious about their relationship to electromagnetism as some sort of like immaterialism for a very long time. Famously, after the telegraph was invented, people thought that if they could communicate instantaneously across space, they could communicate instantaneously across time and hence communicate with the dead. And so the spiritual telegraph became very popular, where people would, go to a medium and they would do Morse code by knocking on a table, and then the spirits would supposedly knock back. And so I don't think it's so crazy to see that artists have been using electromagnetism in their work for a very long time. By far, the most famous work with electromagnetism is Electrical Walks by Christina Kubich. She made these headphones. It's essentially like one coil per headphone. It basically works like these devices, just in like a slightly different form factor. And you're meant to walk around the city and put your head close to electrical devices and hear what they sound like. So I'll play a little bit of that. So she would do scores, and you would sort of follow a path and investigate certain objects. Yeah, I think it's very successful. Next work I'm going to show you is much older. It's a Max Neuhaus work, or Neuhaus, where he placed a bunch of low-power radio transmitters on telephone poles along a road. And so as you drove your car down the road, your car radio would switch between each of the transmitters, and you'd hear different sounds as you drive. And you'd sort of hear like the transition and like the fighting between each of the two transmitters. And I was going to show a work of mine where I did this, but then I found this work, and I realized that Max beat me to it by like 60 years or something. Um, Next one I'm going to show you is by a Japanese artist named Tetsuo Kogawa, who's been doing radio art for a very, very long time. And he does a similar thing, but just at a really close range, where he builds these super low-powered transmitters, puts them next to radios, and changes their orientation. So you hear different levels of interference. It's maybe a tiny bit loud. So I'll play a bit of this. So you can sort of hear like at some points they like really cancel each other out. At other times you get these like really sharp tones. Uh, yeah, and I think it does a really good job of showing the materiality of the transmitters. Um, I have another work here. This is a group called Disinformation, and they make drone pieces based off of the 60 cycle hum and recorded versions of the 60 cycle hum. If you're really digging all this radio art stuff, I highly suggest you check out Wave Farm, which is this place in upstate New York. And it's a whole site dedicated to transmission arts. So they have a residency. They have a radio station. They have a bunch of like permanent telecommunications installations all across the park. Yeah, they do some really interesting work. They did a bunch of pirate radio stations like back in the 90s. Pretty amazing. Okay. Does anybody have any questions before I go into some of the builds?
I do have one.
Yes.
So I'd like to know to what extent are the receiver of the electromagnetic wave is influencing the sound that is actually received?
Yeah, that's a really good question. I think uh well, I think it really depends on what the receiver you're using is. I mean, obviously, like, you're sort of like making a DIY device that's like prone to induction and the traces of its own, like to hear you know like human-made electronic devices like in
Yeah.
their radiation. So you're sort of like you could totally just be hearing like an awful amplifier dying and convince yourself that it's like coming from some crazy source from somewhere
I
else.
mean, like, ideally, does it mean like if we have different receivers receiving the same, like same source or same wave, ideally they should sound the same, or it's not the case?
Yeah, ideally they should sound the same. I mean, obviously, like, your antenna, your coil, like something like this, is receiving, a much wider range than our range of human hearing. And so
Yeah.
your circuit, by effect, of like putting it through a speaker or headphones or something, is like doing some filtering. And so that
Okay.
obviously changes the sound.
Hmm.
But it's a great point, and we're going to talk about it in a little bit of a different context in the
Oh,
rest of the
okay.
talk.
Yeah,
Um,
sure.
but
Hmm.
yeah, any form of like transduction is you're always going to get like some kind of loss or change. And I think like deciding like how much you care or like how proportional that loss is really interesting, especially in regards to like this kind of listening. Um, Okay, so now I'm going to get into the justification for the device I'm going to be spending the rest of the talk talking about, that I was developing for a while during my graduate degree. Um, So the Loam tools, and like like Christina Kubish's headphones, um, it's like a close listening thing. You have your coil, you have the flux, and then you hook it up directly to an amplifier. Um, and essentially, you're only listening to electromagnetic radiation, in our range of human hearing. So, like 0 to 20 kilohertz. Um, Same thing with natural radio, just like a little bit more sensitive of an antenna. I guess you call it like atmospheric listening or sort of far listening. And I would call this close listening, given that, it relies on flux through the center. So you're sort of pointing it at things, you're getting close to things. Um, but I was sort of wondering why there doesn't exist, a device that's variable in frequency that can, traverse like a wide spectrum above our range of hearing, that allows us to listen to, the same type of noise, that, obviously has been so conceptually interesting to so many different people. Um, and I think there's certain tools that exist for this. There's something called Web SDR where you can traverse, the radio spectrum in a certain location and use different modulation schemes, and you can definitely get some interesting noise for sure. But there doesn't really exist like a portable microphone type device or some device you could employ in a rig, per se. So that's why I started working on a variable electromagnetic receiver. Um, so it's essentially like a horrible radio, is what I built. Is It has like a tuning dial, and it mixes down high frequency stuff into our range of hearing, but it doesn't employ any kind of filtering or demodulating at all. And of course, there are some uh, caveats to that, and this sort of addresses your question, Warren, in that like by doing frequency mixing, we are doing some demodulation, especially when it comes to AM. And also, the coupling capacitors that I have to employ obviously do some filtering as well, but I try to mitigate that as much as possible. But I like to think that what I hear through this is a mix of, human-made content like telecommunications and other devices, and sounds from the natural world, like high frequency natural radio is kind of my dream with this. Also, I wanted to make it so the frequency control, wasn't limited to, just the dial. You could program, like sweeping algorithms or even connect it, to like something like Max MSPs. You could, like MIDI control or, really anything you can do in that software. So I'm just going to play a demo of the device all the way through. I just recorded this today. It sounds different every day and in whatever location I'm in. But yeah, I'll just let this go. And I'll end it there as I've landed on some random song that was being transmitted. Yeah, as I said, the device is super simple. This is the block diagram where you have I'm using a coil only because I wanted my antenna to be super long, but you don't have to use a coil. You can, you can use a whip, or you can directly connect yourself to like the frame of a building or whatever. Like anything conductive works really well. Some RF amplification stage, and then into your frequency mixer. And then into the mixer, you are putting your local oscillator, which is like your tuning oscillator. And I have a really nice frequency generator. It's this board called the 809850. It can generate anywhere from DC to 40 megahertz, which is really good. I would have made an analog oscillator, but making an analog oscillator that is of that range for a sine wave is really, really hard. I tried to do it and it really doesn't work. You don't get an even wave all the way through. And this board is pretty well controlled by an Arduino, which I think is a blessing and a curse, and I'll talk about why later. You get a lot of signal loss out of your frequency mixer, so you do a second amplification stage into a low-pass filter, and then you can hear it. So super, super simple. A quick note on the also I don't mean to say simple as in like it should be immediately understood. I mean to say simple in the realm of other telecommunications devices. It's basically like a radio with missing parts. So a quick note on frequency mixing. So on this chart, you have power on the y-axis and frequency on the x-axis. If you have some band of radio frequency that you're receiving and you want to listen to it, you want to down convert it. And you do that by putting it into a mixer circuit along with a local oscillator. And the local oscillator will produce two results of that frequency mixing. It'll produce the local oscillator minus the RF and the local oscillator plus the RF. So you can imagine if, I'm receiving, like say I want to listen to stuff at like, 1 megahertz or something like this. And I send a 990 kilohertz local oscillator into my thing. The difference between those two is 10 kilohertz. And so then I'll hear my 1 megahertz signal as so if it's a sine wave, I'd hear a 10 kilohertz sine wave or something like this. But obviously, it's broadband noise and a little more complex, but that's the basic idea of mixing down into 20 to 20 kilohertz. So this is the circuit on the inside. I've only shown a picture of the double balanced mixer circuit, which is the mixer circuit that I used, and then just the inside of the box here. The mixer circuit is a diode ring with two transformer inputs. So the local oscillator, which comes in through here, turns on each pair of diodes, one by one with each swing of itself. And that does the multiplying by the RF, and then you get your IF, your mixing products here. And you can see the mixing circuit here. These are my tiny little transformers that I wound. Yeah, I think they're really cute. But yes, so a quick note on capacitance. So you'll notice in the video, I was squeezing the coil a lot. And it turns out it's really hard to hear anything if I don't do that. I've come to understand this by capacitors in series in a circuit are high pass filters, where the higher the capacitance is, the lower the cutoff is, and so the more low frequencies are letting in. I'm coiling wire a bunch, so at each coil there's two conductors separated by either air or the copper insulation, which is a capacitor. Two conductors separated by a dielectric. So by squeezing the coil, I like to think that I'm increasing the capacitance, and letting in more low frequencies, and so I can hear more things. I don't totally know if that's the case, but that's the best argument I've heard of. I've also been told by telecommunications engineers that, like, obviously my skin is conductive, all of our skin is conductive. And by touching the antenna, I'm increasing its capacitance or, sensitivity or something with my body. Another engineer told me that, like, because I'm wearing shoes, I'm a capacitor to the ground, and that like really increases your capacitance, and so you can hear like a ton of stuff. Yeah, if any engineers have a different idea about why that would be, I'm totally all ears. A couple of notes on the circuit. I included this because I thought, if it's a music tech seminar, some people might be interested in some of the component choices and some of the technical details. But if you're not, just bear with me. So the first version I made, all of my amplifiers were like mixing board amplifiers, like audio mixing board amplifiers, which obviously don't have a bandwidth for RF. And so I was getting a ton of noise. And I think I was hearing the noise of my device more than I was hearing any sort of signals from beyond. I increased to the LM318, which is a little bit of a higher bandwidth, and now I'm on to the AD8055s, which have a gain bandwidth product of like 300 megahertz. So I think with like the amount of amplification I need, I can get into like the 10 megahertz range, which would be really nice. And they're just like op amps from like video controllers. So that is to say that the tool you need may not be in the context you're looking for it in. But obviously, the higher frequency I get, like the less it makes sense to do any of this analog. And so I may have to move to digital. Also, you'll notice when I was turning the knob, I was traversing the frequency spectrum extremely fast. And that's because the Arduino has an analog input bit depth of 10. So I have 1,024 discrete values to map onto a range of like over 1 million hertz, which obviously doesn't make any sense. I think I'd like to change this at some point. I added that rotary encoder, which has some more artistic functions, but eventually I think I'd like to make it a bit more of a robust frequency control. And Yes, I talked about the coupling capacitors, doing some high pass filtering. I have them at 10 microfarads right now. My intuition is I don't want to make them too high, that they're like response to voltage spikes is doesn't do anything at all. But maybe that doesn't matter. Again, if there's any engineers who have any ideas about that, I'm all open ears. There's not a ground plane in this at all, which is also kind of bad practice when you're doing RF. But I wanted to make the device as like susceptible as possible to get the most sounds. Okay, I'm gonna go on to some applications of how I've used this. But I'm not totally sure if I went too fast or too slow through all of this stuff. So does anyone have any questions before I move on? Um, for me, the device is not the most interesting part. I'm much more interested in deploying it in various contexts. And mostly I'm interested in using objects as antennas. I think the value for this, the value for me in this sort of like non-demodulating, non-filtering device is that, maybe I can hear some of these signals as people, heard them in the videos I played at the beginning, or maybe, like how they exist in physical space, because if you imagine you have a radio tower that's broadcasting, it doesn't just like skip the landscape and arrive at your radio receiver. It interacts physically with every object in its path. And I'm very interested in, what that object does to the signal and how it may sound. So the first piece I'm going to show you is an exhibition I did in England 2 summers ago, where I wrapped a tree in a long loop of wire and I used it as a natural radio receiver. And then I made a smaller antenna and used that as hooking up to my V1 of my variable receiver that I just showed you the architecture for. I'll play that briefly. Yeah, so tree wrapped in copper. It was a very good antenna. I couldn't hear anything else if I didn't use it, which I thought was really interesting. It was like almost like the tree was hogging all of the signals in the area. Um, and like one of the most interesting pieces of feedback I got from this was that like somehow people who had never heard of natural radio like knew that it was natural in some way, which I think like speaks to the cadence and like the variable dynamics of an audio file like that, that you can make something feel natural. Um, and also it turns out there is a history of the United States military using trees as emergency antennas during the Vietnam War. They were experimenting with radio equipment that was specifically meant to tap into trees, which I think is really interesting. And also, again, proves that the military invented all our technology first. I think, often about how the Germans invented stereo panning, or so I've read during World War II. Second project, it's another tree antenna where I wrapped a tree in West Virginia and set up a live stream for audio and video next to it, and I live streamed it into a gallery for a month. The live stream was great because you're able to catch raccoons sometimes that climb on your antenna. Very cute. And I'll show you a bit of the setup. Yeah, so I have my camera here and a Raspberry Pi with the Pi sound. And if anyone's interested in making their own hardware, the Pi sound is really great. If you've never heard of it, it can compile Max MSP on a Raspberry Pi, which is really amazing, specifically Rainbow. Yeah, and then I have one of my devices here connected to the tree with a light, and then this is what the view was like in the gallery. I have a 24-hour recording online, and this one was really interesting because there's no other radio stations in this area except for Fox Sports, Charlestown, West Virginia, which made me feel really bad for the tree, as if it was just like getting totally bombarded by Fox Sports its whole life. But I'll play like 30 seconds of that.
Okay. So yesterday, we were making fun of you were trying to go off on something about the NFL or NBA or something. I'm like, but you know, Katy Perry's about to go to outer space. And you're like, yeah, that's great, bro. We're talking about Ellen Stone. I'm like, yeah, Aaron Christian, hold on. Katy Perry and Gail King are about to go into orbit. Well, if you listen back to yesterday's show, they wanted the damn.
So it's sort of curious because you can hear that, the device is traversing over the frequency space, but still the only thing you can hear is Fox Sports Charlestown, which is so amazing. And at night it gets kind of beautiful, like you hear tones, sort of. You can't really hear so much. So that's that project. I'll show you one more, an antenna that's not a tree. I showed this piece in a gallery in May. This up here is the antenna with the receiver in the center, and then this down here is like a speaker of sorts, a very inefficient and large speaker. I'll show you some quick documentation of that. Just for a breath. So this is like an array of magnets here. So the signals received from the antenna are directly, moving these wires electromagnetically. Okay, so last section here, I want to talk about future work, which includes some very unprofessional notebook drawings. And yeah, so I feel like I now know what this thing can do as like, just like a sort of pure variable receiver. And I'm interested in how I can extend this architecture further. The first idea, electromagnetic noise as its own local oscillator. And this was essentially mean that instead of, you have your antenna and amplifier into the mixer and then your tuning oscillator into the other side, you just have another antenna and an amplifier that goes into the mixer with maybe some like variable capacitor, like variable filter thing. And I don't know, I imagine that the variabilities in each of the antenna will create some interesting results in the nonlinear design of the mixer. Second thing is audio input as a local oscillator. I'm interested in making this more of an instrument than, a sound source. When I performed with this, it's like, heavily processed, like alongside some guitar playing or alongside other musicians. But I'd like there to be a way for your audio signal to directly impact how the thing is received. And there's two ways I've thought of doing this. The first is, the architecture is normal. You have your radio frequency and amplifier going into the mixer. And then you have a second mixer down here where the audio is being up mixed to like, say you want to listen to 1 megahertz. You take your instrument signal in, you mix your instrument signal up to like 990 kilohertz, and then use that as your local oscillator, and then see how that interacts with the RF up at that frequency. The other option that I've thought of is changing from a sine wave local oscillator to a square wave local oscillator and pulse width modulating it by an audio signal. That can also be sort of interesting. The third way, and this is really the thing that made me nervous to have Richard and Tom in here, because I think this is like maybe a really ridiculous idea. But a 3-input mixer with a 6 diode ring. I have no idea if this makes any sense at all, but I'd like to try it. I think it could be interesting potentially. If anyone's ever heard of something like this, I couldn't find anything like this online. Please let me know. Like I hinted at the beginning, I'd like to get to higher frequency ranges. I think like a 5G microphone could be really amazing. Something in the chat. Definitely try and see what happens. I will. Yeah, this is the end of my slides. I'll open up the floor for questions. But yeah, thanks everyone for listening to all that and bearing with me.
Miles, I wonder if you want to pick anything else from outer space or maybe even some local conversation that people
Wait, I'm sorry, I can't hear you super well.
Can you hear me?
Oh, yes.
Yeah, Miles, I wonder if you've ever picked anything up from outer space or from conversation down on Earth that people had no idea that you could even listen to it. Any surprises like that?
Ricardo, you're really hard to hear.
Yeah.
I think the mic is just far.
Sorry. So is this better over here?
Yes, it's much better.
Okay. So I just wonder if you've ever picked anything up from outer space or some conversation that people had no idea that you could tune into it.
I've definitely I don't think well, I guess like every ham radio operator knows that their communications are public. But I've caught like two people singing to each other late at night over the airwaves, which was really sweet, actually. And also, I listened to like a whole Chinese play at like 3 in the morning in my studio over that device, which was also really interesting.
Any other questions? Come on. Okay, go ahead.
Well, first of all, this is so interesting. Thank you, Miles. I never thought I'd have an interest for trees as antennas, but like, does this affect plants in any way? Like using plants as antennas? Do we know how it affects them?
Yeah, that's a really good question. Well, I think there have definitely been experiments done, like does audio affect plants? There's a guy named Ben Jordan who did a bunch of control experiments where he was just playing sine tones and then songs to plants and see if they grew faster. The ones that received audio or like certain types of audio did actually grow more than the control groups, which is kind of interesting. I don't know scientifically if electromagnetic radiation interrupts trees. I guess like, you could say like in the research that's been done, with like how trees and mycelium networks communicate, that there's like some kind of electrical communication there. And if the tree is then receiving, stuff that's, going through it, and creating some kind of currents, maybe that could be interrupted. I will say I did set up a tree antenna around a group of trees on a farm in Maryland. And I left and I came back in 6 months and the largest tree had fallen over. And my mother convinced me that I killed the tree by wrapping it in wire. So I don't know. It's up in the air.
Awesome, thank you.
I mean, trees and other plants are like, they have lots of moisture in them, and they're definitely going to affect the capacitance and inductance of whatever's around them. So, I mean, even if you built some kind of, receiver, LC receiver of some kind and let plants be near it and have them move, it's almost like a theremin or something. They're going to affect the difference in whatever happens in those signals. So you definitely get some effects out of that.
It's true. Yeah, it's true. Which I guess makes sense why the biggest, tallest trees are the best receivers. They have the most moisture content.
So the antenna is wait, let me go over here. So the antenna is the tree and you have it wrapped in copper, right? And that's what picks up signals. Do you ever get signals from the tree itself?
I have never. I had a conversation with someone who has been attempting to do this for a long time. But I don't think I have the right receiver for this. Like apparently the signals are super slow. Like ELF range. Which I think is even below, 20 hertz, our range of hearing, in like Schumann resonance territory, which is like the Earth's heartbeat at like 7 hertz or something like that. But yeah, it's an interesting idea. I've thought about it. I think you'd have to do some like some sensitive recording and then some upmixing, and then maybe you'll get something close to that.
Have you done any experiments with the sound of the planetary system?
Yeah, I'd like to. I'd like I don't know. I'm interested in how radio telescopes work. Again, I think it's all such like high frequency. Oh no, it's not high frequency, but like maybe you just need like those huge dish antennas to really make something happen. But I like to think that like some of the natural radio stuff like is, planetary events that have somehow made it to Earth. But I think the question is interesting because it reminds me of like NASA has this whole like big sonification library, and it's sort of hard to tell like when they say like this is the sound of a black hole if they've just like put like some pulses into a synthesizer that are proportional to the black hole, or it's actually like a direct translation of what's happening. There's a PGH musician, Steve Quilly. Oh, cool. I'll check them out. Thank you, John.
Any other questions? Come on.
No pressure. It's okay.
Okay, well, Miles, we have to thank you very much for being here today. I would like to have a follow-up on some other ideas that I have for things to listen into.
Yes, please. I'd love to hear them. You can send me a big long list and I'll try and build you something.
Okay. All right. Thanks again for being here.
All right. Thanks, everyone. Thanks for listening.
We can stop recording.